gas law. The ideal gas law includes an amount of gas. It's not held constant anymore. And the ideal gas law also uses R, which is an ideal gas constant. So it's a number that we're going to use. And PV equals nRT is the ideal gas law. We can move those variables around as we see we need to. You can see here it's been rearranged for PV over NT equals R. Okay, so this ideal gas constant has three values depending on whether we're talking about kPa, atmospheres, or mmHg, and you'll have access to these three different R's. This R is a constant, which means that it's never going to change. It's always going to be one of these three values, depending on whether we're using kPa, atmospheres, or mmHg. So you might want to put this on a note card as well, or have this sort of available. It can be derived by knowing that 1 mole of gas at SVP has a volume of 2.4 liters. Okay, but you don't have to derive it. I'm telling you what it is. It's really important to always watch your units. Okay. So Samantha goes camping and wants to inflate her air mattress. She wants to put 20 liters of gas in the mattress at a temperature of 17 degrees C and an atmospheric pressure of 101.3 kPa. How many moles of gas does she need? So right here, I can see that I have kPa. So I am going to use this R, okay, because I have kPa. The other thing that I need is I need my temperature in Kelvin, okay, and my temperature right here is 273. So Kelvin is degrees C plus 273, okay. So 17 plus 273 is going to be 290. Okay, so now PV equals nRT. What am I solving for? How many moles of gas does she need? I'm solving for N, right? So N equals PV over RT. And then I'm just going to plug and chug. So my pressure is 101.3 kPa. My volume is 20 liters. My R is 8.314 kPa liter over. And my T is 290K. Okay, and now it's just a plug and chug problem. So I just have to use my calculator. And what I get out is 0.840 moles. Here's another one. If polyethylene plastic weather balloon contains 2.51 moles of helium, which is at 20 degrees C and 94 kPa, what is the volume of the balloon? So again, I have PV equals nRT, and I'm trying to find volume. So I want to get volume by itself, which makes nRT over P. And now I just have to plug in my values. So V equals 2.51 moles. R, I have kPa, so I'm going to use this first one, 8.314. And T, so I have 20 plus 273, which equals 293. Okay, it's getting a little cramped there, but this says 293K. That's what that says. And pressure, 94.0 kPa. And I don't know if you can see it, but you can see that my units are all canceling, and so what I'm left with is liters here. Oops. And so if I plug this all into my calculator, 2.51 times 8.314 times 293 divided by 94, I'm going to get 65 liters, okay? So ideal gases versus real gases. So in ideal gases, particles do not attract one another, and particles have no volume. Ideal gases do not actually exist, okay? what we have are real gases. So in real gases, particles attract each other, okay? They form liquids at high pressures or low temperatures, okay? Particles take up volume. They behave ideally, like as we say, ideal gases under low pressure and high temperature. So at low pressure, particles are far enough apart that their volume is inconsequential. Okay, and at high temperatures, their kinetic energy is much greater than the intermolecular forces, those forces between molecules that hold them together. So for gas problems, we're just going to assume ideal behavior.